Okay, minta maaf lah saya lewat sikit ya.
Waalaikumsalam.
Salam.
Okay, baru ada 22 orang ni. Mana lagi 6 orang lagi ya? 5 orang lagi. Lagi 5 orang tak hadir. Tak masuk lagi ni. Okay, Assalamualaikum. Please join. Okay, saya ada benda penting nak bagi tahu hari ni. Okay, kelas kita cuma sejam saja. Okay, saya tunggu lagi 2 minit. Please join. Okay, saya panggil dekat apa? Buat voice record dalam grup WhatsApp. Nak bagi semua join. Okay, kita tunggu lagi 2 minit ya. Lepas tu kita start. Okay, nampak ya semua? Saya punya screen sekarang ni ada MATLAB. Okay, good. Okay, Assalamualaikum warahmatullahi wabarakatuh. So today I'm going to explain the complete program for evolutionary programming, for the purpose of capacitor installation in power system. So this is actually totally related to your mini project. Okay, so I have write the source code in order to conduct optimization for capacitor placement in power system. Okay, ini saya dah buat lah ya untuk EP, but this is just for single capacitor installation because later on in your mini project, you are going to conduct single installation as well as multiple installation of capacitor. Tapi hari ini saya cuma tunjuk untuk single je lah. Okay, after that dalam mini project nanti you have to modify or extend this program for the purpose of multiple capacitor installation. Okay, so I will start from the beginning of the program. Okay, walaupun last week saya dah explain sikit kan, tak apalah saya start balik. Okay, so kita akan start dengan clear CLC macam biasalah. After that, initialization. So initialization, we have to define the value of beta, population number as well as the maximum iteration. Dalam case ni saya letak beta untuk EP 0.5, the mutation scale. And then the population size is 20. The maximum iteration used is 1000. Alright, after we have specified the parameters for EP, the next step is to specify the reactive loading. Okay, kenapa kita kena buat reactive loading? Because in order to observe the significant effect after capacitor placement or capacitor installation in power system, we have to give a bit disturbance to the power system. Kita kena ganggu dia sikit. Okay, because when we give reactive loading, okay, the voltage will be reduced and the losses will increase. Sebab kalau you letak capacitor dalam keadaan power system tu dah sedia okay, maksudnya dia dah sihat dah. Voltage dia semua okay, losses pun cantik, tak tinggi sangat. Lepas tu you pergi letak capacitor lagi. So you cannot see the difference, okay, as a result of the capacitor installation. So in order to observe the effect of capacitor, we have to give a disturbance to the power system so that the voltage drop. So when this voltage has been dropped, we will install the capacitor with the aim of improving back the magnitude of the voltage. Jadi kita install capacitor ni adalah untuk improve back the voltage that has been dropped as a result of reactive loading. So these are the line where you can specify the reactive loading. Okay, QD means that the reactive power of the load, and then bus QD, the bus to be selected for reactive loading. Sini saya ada tulis dah. Okay, dia punya comment dia. Reactive loading inputs to the power system in mega VAR and location for reactive loading. Okay, saya letak sini 50 mega VAR, and then location for reactive loading is bus 14. After that, we specify the range of reactive power for the capacitor. Okay, QC LB and QC UB. LB stand for lower boundary, UB stand for upper boundary. Okay, saya tulis komen kat situ, you baca lah ya. Alright, so that means kalau you tengok sini saya letak LB dia 20 mega VAR, UB dia 40 mega VAR. So that means the range of the QC is between 20 until 40 mega VAR. So this program EP, okay, will try to find the best value of QC within 20 until 40 mega VAR only. So dia ikut range yang you set lah. Kalau you set daripada 20 sehingga 100, dia akan cari daripada 20 sehingga 100. Mana satu yang paling bagus. Alright, and then you have to specify which location in the power system to be placed the capacitor. So as for example, in this program, I choose bus number 10. Okay, saya letak capacitor tu dekat bus 10. Pulang pada you nak letak dekat bus mana pun. Alright, so these are the settings that you have to complete before you can run the program. Okay. Alright, next, random population generation. Okay, immediately after we have set all the parameters, all the settings at the beginning of the program, the next step is to generate the value of the control variables randomly. So kalau you ingat balik waktu you buat quadratic case, kita generate apa? The value of X. Okay, we generate the value of X randomly because in that case, X is the control variable. But in this case, the control variable is no longer X, it is QC. Okay, the reactive power injected by the capacitor. So we are going to generate the value of QC randomly for all the individuals that we have set. Okay, katakanlah dalam setting tadi number of individuals in the population is 20. Jadi sini pun dia akan generate random value of QC for 20 individuals in the population. Okay, maksudnya ada 1, 2, 3, 4, 5 sampai 20. Okay, first individual ada QC dia. Second individual ada QC dia. Sampailah 20 individual ada QC dia. Alright, after we have generate the value of QC randomly, we have to evaluate the quality of the value of QC. Every QC that we have generated will be evaluated through the process of fitness evaluation. Okay, we evaluate the fitness. Kalau dalam quadratic case, how do we evaluate the fitness of X? Is through the substitution X into Y equation. Okay, Y sama dengan berapa? X square tolak 5X tambah 6. Ataupun you buat dalam you punya assignment kan, cubic equation, gantikan nilai X ke dalam Y in order to get the value of Y, where in this case Y is fitness. Tapi dalam case ni we don't have the fitness equation that relates QC and the fitness. Okay, in this case the fitness can be either V mean, voltage magnitude, or losses. Suppose that we assume in this case the fitness is voltage. Okay, katakanlah saya anggap sebagai V min tu sebagai dia punya fitness. So mana you tak ada equation yang menghubungkan V min sama dengan QC tambah itu tambah ini. We don't have the single equation that relates QC and V min. So in that case we have to use power system load flow simulation. Okay, kita gantikan nilai QC ke dalam power system, conduct load flow and obtain the voltage as well as the losses. So for that purpose, we will call the subroutine test_14 bus. Ini saya dah buat dah lah ya. Saya harap you dah tahulah macam mana nak buat subroutine. Okay, you can refer back to the video in MATLAB tutorials because I have give the tutorial on how to create a subroutine or function in MATLAB. Okay, so after conducting the load flow simulation, okay, maksudnya kita hantar QD, hantar bus QD, hantar QC, hantar bus QC ke dalam power system dan dapatkan dia punya V min and P loss. Okay, maksudnya setiap individu 1, 2, 3 sampai 20 individu, setiap tu ada dia punya QC, ada punya V min. Ada QC, ada V min. Ada QC, ada V min. Sampailah last kali QC and V min. Alright. So later on we will assign the value of QC into parent individual. Ini tak ada apalah ya. Kalau if you refer back to the previous source code in quadratic case, okay, parent individual equals to X, the control variable. Okay, ini saya tulis sikit lah. Okay, control variable. And then parent fitness will be the fitness. Kalau dalam quadratic case, parent fitness dia sama dengan Y. So in this case, parent fitness will be the V min. Sebab kita pilih V min sebagai fitness. Okay, yang ni semua tak ada apalah ya, sama. Okay, exactly the same as in quadratic case program. Except that you have to make sure the sort rows, okay, sort rows ni dia kena ikut maximization or minimization of your problem. Okay, remember that voltage is to be improved. Maksudnya bila you bagi reactive loading, voltage drop. Jadi kita bagi capacitor kat dia dengan harapan bahawa voltage will be improved back. Kita naikkan balik voltage tu. So bila kita nak naikkan voltage tu, dia akan jadi maximization, bukan minimization. Okay? Walaupun saya letak situ V min, orang salah faham. V min, minimum, minimization lah. Bukan. Okay? V min tu maksudnya the lowest voltage magnitude in the power system. But this lowest voltage magnitude, okay, our aim is to improve or increase back to the original value. Alright, so ini semua tak ada apa, sama. Okay, next we go to the main algorithm or the main loop of the program. Okay, the first process is known as mutation loop. Okay, macam mana kita nak buat mutation untuk case power system? Because before this we have take a look on mutation with regard to quadratic case. So sebenarnya konsep dia sama je lah. Okay, kalau you faham bahawa control variable is X. In this case, the control variable is QC. So you can change X into QC. Tapi kalau you tak nak ubah tak apa. Okay, because it will be the same exactly as in quadratic problem. So ini you tak perlu ubah apa pun. You nak biar dia kepada XI pun tak apa, FI pun tak apa, X min, X max pun tak ada masalah. Okay, biarkan dia. Okay, lepas tu sigma, Gauss EP, X new. Alright, lepas tu sampai sini, X new dimasukkan ke dalam offspring underscore individual. Okay, cuma saya nak tanya sikit, X new ni sebenarnya apa? Untuk case power system ni, what X new represent?
QC.
Okay, good. Sebab dah tulis QC kan? Dah tulis kan ataupun you memang faham?
Dua-dua, yes.
Okay. Alright. So X new is actually QC lah. QC new. Kalau you nak ubah, nak bagi nampak cantik sikit pun, terpulang kepada you lah. Okay, you nak tulis sini QC new equals to QCI plus imaginary set 1. Lepas tu QC new masukkan ke dalam offspring individual. Tapi saya malas nak ubah sebab dia tak kacau original program tu. Jadi saya biarkan macam tu. Okay, cuma you faham X new is actually QC new. Alright, after we have perform the mutation to obtain the new value of QC, we will handle the constraint, okay, through constraint handling subprogram. Cuma sini you kena ubah lah ya. QC underscore upper boundary, QC underscore lower boundary. Okay, ni you tak payah usik lah ya, abaikan. Cuma you faham, ini apa yang dia buat, dia nak readjust the value of QC new in case of they are outside the boundary. Okay, katakanlah you tengok sini ya, you punya lower dengan upper boundary 20 sampai 40. So the range of QC to be searched by EP is between 20 mega VAR until 40 mega VAR. Katakanlah bila dia buat mutation, tiba-tiba dia dapat 100 mega VAR, which is outside of the range. Jadi this constraint handling subprogram, dia akan readjust balik. Oh, dia ni dah 100 ni, terlebih daripada 40. Jadi kita akan auto set dia jadi 40. Sama juga kalau macam lower boundary tadi 20, tiba-tiba you dapat 10. So 10 will be readjust automatically to 20. Alright, so fitness again, we perform fitness evaluation for offspring individual. Jadi hasil daripada QC new yang dihasilkan, kita akan perform fitness evaluation through load flow simulation. Kita hantar nilai QC new ni, masukkan ke dalam test underscore 14 bus. Perform the load flow simulation to obtain the corresponding Vmin and Vloss. Lepas tu masukkan Vmin ke dalam offspring fitness. And this process will be repeated until all individual 1 sampai 20 has been performed mutation. Okay. Alright, next we go to combine and sort. Ini macam biasalah, tak ubah. Okay. No change, tak ada perubahan dengan kuadratik. As a result of mutation, now we have two different population. One is parent, the other one is offspring. So kita combine kedua-dua ni, letak atas, letak bawah. Parent, offspring. Combinekan dia, and then sort. Sort row ni you kena jaga-jaga. Okay, saya letak negative 2. Negative means maximization. Kita nak maximize the voltage. Okay, so combine negative 2 sort rows and then reassign or selection. Okay, reassign the new parent population. Kita ambil top 20. Dia bukan top 20 sebenarnya, dia ikut 1 sampai pop. Sebab bila you combine dua-dua, parent dengan offspring, tadi 20. So you ada 40 population. Jadi kita nak maintain ikut original population size, kita ambil 1 sampai pop sahaja selepas kita sortkan dia. Maksudnya top 20 ni is the best individual. Okay, after has been sorted. Okay, ini pun tak ada apa-apa perubahan, abaikan. Okay, display pun tak ada apa-apa perubahan. Convergent check juga tak ada perubahan. Okay, kita ambil maximum parent fitness, minimum parent fitness, and then check the difference for convergence. If the difference of the fitness between the best candidate and the worst candidate is almost the same, we can say that the program has converged. Okay, lepas tu bawah ni tak ada apalah. Dia cuma nak record optimization complete at iteration yang keberapa, and then accuracy. Alright, so these additional programs at the end of the optimization is very important in order to recheck, okay, whether the voltage and the losses has been improved as a result of capacitor placement. Jadi bila kita dah buat EP selepas 1000 iteration, katakanlah dia dapat okay, selepas 1000 iteration, QC yang dihasilkan oleh EP adalah 35.5. Itu nilai QC yang EP cari. Jadi kita nak check balik, adakah 35.5 mega VAR ini memberikan improvement kepada voltage dan losses ataupun tidak. So we have to reperform the load flow simulation. Okay, kalau you tengok sini ya. So load flow simulation without capacitor. Jadi bila without capacitor, saya just letak QC dia kosong lah. and then saya record apa dia punya Vmin, apa dia punya P-loss. Kita nak tengok voltage dengan losses sebelum capacitor, before we place the capacitor. Alright, next, load flow simulation with capacitor. Okay, ini kita akan ambil nilai QC yang dicari oleh EP tadi, masukkan ke dalam power system and then perform load flow to obtain the Vmin and P-loss. Because we want to compare Vmin before and Vmin after capacitor has been placed. The same goes for the losses. Okay, losses before and losses after the capacitor. So last kali kita display, okay, display QC, display Vmin and display the losses. Okay, so kita nak tengok ada improvement ataupun tidak. So that's how the programs works. Okay. So saya dah bagi program ni, saya dah upload dekat Google Classroom. Okay, you boleh gunakan untuk single capacitor placement, but your task is to modify for multiple capacitor placement. Okay, dalam soalan mini project tu saya minta you buat sekali multiple capacitor installation. Jadi macam mana you nak ubah tu? Okay, you nak jadikan daripada single capacitor kepada multiple capacitor. Alright, so any question before I move to a mini project question? Any question on this source code? Tak ada soalan? Okay, tak apa. Alright, next we move to mini project question. Okay. So ini pun saya dah upload dalam Google Classroom. You may download from the folder. Alright, so the title of your mini project will be Optimal Capacitor Placement in IEEE 30 bus power system using EP. Okay. So saya nak you gunakan 30 bus. Okay. Yang saya bagi program tu 14 bus. Jadi you kena ubah untuk 30 bus. Tak susah pun, senang je. Okay. Gantikan ni je lah yang 30 bus dengan 14 bus. Alright, this assignment has one question only with multiple tasks. Students need to use both the programming skill as well as theoretical knowledge. Perform the experiment by considering different changes in various parameters and variables. Okay, after completing the experiment, students need to present their result in a brief report. So the report has to be submitted to my email lah ya, zulfkeultm@gmail.com. Okay, group ni you pilih group yang sama lah dengan assignment 1 dengan assignment 2. Okay, kalau boleh bagi sama lah, senang sikit saya nak marking nanti. Alright, okay, let's take a look on the question. Cool. So basically you have 2 tasks, okay, task 1 and task 2. Okay, but for the purpose of beginning, you buat dulu task 1, okay. Task 1, random capacitor placement. So that means you install the capacitor without using EP. So task 1 ni kita nak tengok, adakah random capacitor placement ni is enough to improve the voltage and losses compared to using EP. Okay. Alright, yang task 2 ni you akan buat setelah you complete task 1. Ini saya tak nak discuss lagi dah ya. Hari ni kita discuss untuk task 1 dulu. Alright, task 1, random capacitor placement. Okay, first select a load bus and determine maximum reactive loading Qmax. Okay, sebelum you boleh install capacitor, as I mentioned before, you need to give a disturbance to the power system. Okay, you kena bagi gangguan sikit. This disturbance will be in the form of reactive loading. Tapi nak bagi reactive loading ni, you kena tahu dulu berapa Qmax dia. Apa itu Qmax? Okay, saya rasa ni saya dah explain dalam satu video. You can refer back to the video on reactive loading. Okay, saya ada buat video tu saya rasa. Macam mana nak cari Qmax untuk satu bus tu. Katakanlah you pilih bus nombor 10 and then you give the reactive loading. Okay, you nak masukkan reactive loading tu dekat mana? Dekat kolom yang keberapa dan macam mana nak buat? Okay, so masukkan nilai reactive power dia, perform load flow. sampai voltage you drops to berapa. You tengok balik video tu, okay? So that's how you define Qmax. Ini masih belum kapasitor lagi ni. Baru nak buat reactive loading. Alright, next record the per unit minimum voltage magnitude and real power losses in megawatts under the following reactive loading. So once you have determined the Qmax, then you have to set up 5 different reactive loading. Katakanlah Qmax you dapat 50 mega VAR. Jadi untuk setiap 20%, 40%, 60% sampai 100% of Qmax, you kena buat load flow dan record dia punya Vmin and losses. So let's say 20% of 50 mega VAR. Berapa? 10 mega VAR kan. So letak 10 mega VAR, run the load flow, record dia punya Vmin and P-loss. Lepas tu increase pada 40%. 40% berapa? 20 mega VAR. So 20 mega VAR, run load flow, again record Vmin and P-loss. Sampailah 100% of Qmax. Sebab apa? Sebab nanti you nak kena install capacitor at every percentage of the loading. Install waktu 20%, berapa dia punya Vmin dengan losses. Lepas tu install waktu 40% pula, berapa Vmin dan losses. Alright, so this is the condition before capacitor placement. Okay, next, number 3. Select a load bus and place a capacitor with random value of its QC in mega VAR. Hence, record the value of Vmin and P-loss under the following reactive loadings: 20%, 40%, until 100% of Qmax. This case is known as single capacitor placement. Okay? So, bila you dah tentukan Vmin dan losses before capacitor placement, barulah you buat untuk capacitor placement. Okay, caranya adalah you pilihlah mana-mana satu bus dalam power system tu. Katakanlah you nak pilih bus nombor 14. Okay, bus nombor 14, letak whatever value of QC. Nak letak berapa ikut suka you lah. Nak letak 10 mega VAR ke, 20 mega VAR ke. Nak letak dekat kolom ke berapa, you tengok balik video yang saya buat tu, okay? Dalam video tu saya dah explain macam mana kita nak letak capacitor. So choose one load bus and place a random value of QC in the power system. And then observe Vmin and P-loss under the following reactive loadings of 20%, 40, 60 sampai 100. Maksudnya untuk setiap percentage ni you kena install capacitor and then see the result of Vmin and losses. Okay, note you may change the value of QC for every reactive loading. Katakanlah 20% tadi, QC dia you letak 20 mega VAR. Lepas tu bila you increase kepada 40% of reactive loading, QC dia you nak ubah balik. Okay, nak ubah mungkin 60 mega VAR. Lepas tu 60% you nak naikkan kepada 100 mega VAR. Terpulang, tak ada masalah. Okay, as long as you get the improvement on Vmin as well as the losses. Okay, number 4. Repeat question 3 for another load bus. Katakanlah tadi you pilih bus nombor 14 untuk install capacitor. Bila dah buat semua tu, daripada 20% sampai 100%, you buat benda yang sama, cuma sekarang ni dekat bus yang lain pula. Okay, the other location of bus. Mungkin kali ni you ambil bus 5 pula, bus nombor 5. Lepas tu, masukkan nilai capacitor randomly, buat pula 20%, 40%, 60 sampai 100. Okay, because different location of capacitor will give different performance of Vmin and losses. Jadi kita nak cari mana location yang terbaik untuk kita letak capacitor ni sebenarnya. Okay. Alright. Number 5. Okay, so this is called as multiple capacitor placement. Select 4 load buses and place a capacitor at each selected bus with random values of their QC in mega VAR. Hence, record the value of Vmin and P-loss blah blah blah, 20%, 40%, 100%. This case is known as 4 capacitor placement. Dia sama macam tadi, single, Cuma kali ni you kena pilih 4 sekaligus. Serentak, simultaneously. Okay, maybe you can choose, okay, bus 10, 11, 12, 13. Jadi untuk keempat-empat bus yang you pilih ni, letak QC ni berapa, QC ni berapa, ni berapa, ni berapa. Katakanlah ini 20 mega VAR, ini 10 mega VAR, ini 50 mega VAR, ini 40 mega VAR. Lepas tu, conduct the load flow to get Vmin and losses. Itu untuk 20% of reactive loading. Lepas tu 40% reactive loading, benda yang sama juga. Okay, for capacitor installation simultaneously. Okay, sama jugalah ya. You may change the value of QC for every reactive loading. Maksudnya untuk setiap percentage of reactive loading tu, katakanlah mula-mula 4 capacitor ni you nak letak 10 mega VAR. Lepas tu bila naikkan kepada 40% reactive loading, 20. Lepas tu 60% naikkan lagi dia punya reactive power untuk QC. Boleh, tak ada masalah. Okay. Alright, repeat question 5 for another combination of 4 load buses. Masih lagi 4 load bus, cuma different combination of 4 load buses. Katakanlah tadi you pilih berapa? Bus 10, 11, 12, 13 untuk install. So bila repeat ni, janganlah pilih bus yang sama. You ambil bus lain pula. Katakanlah 20, 21, 22, 23. Install kat sini pula. Okay. Alright, next, tabulate all the results in proper tables with the following parameters: reactive loading percentage, selected load bus QC in mega VAR, and the values of Vmin and PLOS before and after capacitor placement. Okay, ini yang paling penting sebenarnya. Okay, macam mana you nak tabulate you punya result. Okay, sebab saya dah tak nak tengok lagi apa, you asyik duk screenshot je kan, screenshot daripada command window, screenshot daripada Excel. Okay, tak nak screenshot. Okay, you kena construct table based on your creativity lah. Dalam tu you nak letak apa. Okay, kalau ikut soalan ni dia kata dia nak ada reactive loading percentage. Maybe you boleh buat row pertama 20%, row kedua 40%, 60%, 80%, 100%. Lepas tu kolom pertama apa nak letak? Mungkin you nak letak without capacitor, single capacitor, for capacitor. That is for 20%. Lepas tu 40% pula, masih lagi sama, without capacitor, single capacitor, for capacitor, sampailah 100%. So that will be the second column. Third column, you nak letak apa? Mungkin nilai QC. QC berapa? Lepas tu the next column will be Vmin, and the final column might be the losses. So this is how you tabulate the results. Okay, you buatlah macam mana pun. Okay, yang penting bukan screenshot. Okay, design ikut you punya creativity lah, because that will contribute more marks for your results and discussion. Alright, next, plot the graph for Vmin and PLOS with respect to the percentage of reactive loadings. So in your graph, show the comparison between before and after capacitor placement for Vmin and PLOS. So you buatlah graph, okay, graph horizontal axis tu mungkin 20, 40, 60 sampai 100%. Lepas tu vertical axis sama ada Vmin ataupun PLOS. Dan you have to plot without capacitor and with capacitor. With capacitor tu mungkin boleh jadi single capacitor dengan multiple capacitor. Okay, so this is how you are going to present your results. Alright, lepas tu barulah boleh masuk second task. This is the actual task for your mini project. Tapi yang ni saya tak masuk lagi lah hari ni. Saya nak you siapkan dulu task 1. Bagi you faham dulu what is capacitor placement in power system. Okay, so your task, your first task will be perform the capacitor placement randomly with random value of QC. And then saya nak tengok lah result dia nanti. Mungkin lagi minggu depan ke. You dah boleh start sekarang ni, okay? Collect dulu result tu, buat dalam bentuk table. Okay, tak perlu type report lagi. Just present dalam bentuk table dulu, saya nak tengok. Alright, any question on this mini project? Any question?
Tak ada lagi, sir.
Tak ada lagi. Okay. So, tolong buat dulu ya untuk random capacitor ni. Dapatkan result dulu. Sebab kalau you tak buat random ni, you tak boleh proceed untuk yang EP punya. Okay, sebab daripada result random ni, kita akan extend untuk digunakan dalam optimization in EP. Okay, so tak ada soalan lah. Alright, kalau tak ada soalan, I think that will be the end of our online class. So anything you want to ask, you may text in our group. Okay, so I think that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Salam, sir.
Okay.